In the vastness of space, the solar system feels enormous. But when you zoom out far enough, it's just a tiny pocket in a much larger galactic neighborhood. Most of what we study, planets, moons, asteroids, comets, all share a common trait. They were born right here, from the same cloud of gas and dust that formed our sun about 4.6 billion years ago. But every once in a while, we find something different. Something that wasn't born here. Something that doesn't follow the rules. These are interstellar objects, space rocks or comets that were formed in another star system, then flung into deep space. And just by chance, they passed through ours. So far, astronomers have officially confirmed 3 of them, and each one has left us with more questions than answers. Object number 1, ʻOumuamua. In October 2017, an unusual blip appeared on the Pan-STARRS telescope in Hawaii. At first, it looked like a faint asteroid, but its orbit didn't make sense. It wasn't looping around the sun like everything else we've catalogued. It was on a hyperbolic path, flying through our solar system on a one-time visit, never to return. The object was later named ʻOumuamua, a Hawaiian word meaning a messenger from afar arriving first. But what really made ʻOumuamua strange was everything else. It was moving unusually fast, over 87 kilometers per second. It didn't behave like a comet, no visible gas or dust tail. And its shape? Long and thin, like a cigar, or maybe flat like a pancake. Scientists couldn't even agree on that. Then came the real surprise. As ʻOumuamua passed the sun and headed back out into deep space, it accelerated slightly. Not a lot, just enough to confuse everyone. Comets do this when sunlight heats them up and they release gas. But ʻOumuamua didn't show signs of outgassing at all. This unexplained acceleration sparked theories and controversy. Some scientists said it could be a hydrogen iceberg, slowly evaporating in space. Others suggested nitrogen ice, or a weirdly shaped dust fragment. And then came the most controversial idea. Could it have been artificial? Harvard astronomer A.V.I. Loeb proposed that ʻOumuamua might be a fragment of alien technology, a light sail or probe from another civilization. While most astronomers dismissed the idea, it captured the public's imagination, and it highlighted something important. We had just witnessed something completely new, and we still don't know exactly what it was. Object number 2, Borisov. In August 2019, just 2 years later, a second interstellar visitor appeared. This one was discovered by an amateur astronomer, Gennady Borisov, using a custom-built telescope in Crimea. The object was quickly confirmed to be interstellar and was officially named Borisov, making it the second interstellar object ever detected. But unlike ʻOumuamua, Borisov was familiar. It looked and behaved just like a typical comet, with a bright coma, a visible tail, and a volatile surface. That made it even more scientifically valuable. For the first time, we could study an interstellar object using the same tools we use to analyze comets from our own system. Spectral data revealed that Borisov was rich in carbon monoxide and cyanide, even more than typical solar system comets. That told us something fascinating. This comet likely formed in the outer edges of another planetary system, possibly near a young, cold star. In other words, planetary systems like ours can form comets with similar materials. The ingredients of planets, oceans, and even life might be universal. Even more exciting, Borisov likely formed billions of years ago, got ejected during the early chaos of its home system, and wandered the galaxy for eons before crossing paths with Earth. Object number 3, 3I our Atlas. And now, we have a possible third visitor, 3I our Atlas. Discovered by the Atlas Sky Survey System, this object is still under study, but astronomers believe it has a hyperbolic trajectory, just like ʻOumuamua and Borisov, that suggests it too came from beyond our solar system. Early data show that it may be a fragmented comet, possibly even breaking apart as it enters our region of space. What's unique about Atlas is its brightness and velocity. It seems more active than ʻOumuamua, but with behavior that doesn't completely match Borisov either. Scientists hope that by tracking Atlas closely, they'll get more insight into the range of materials and structures interstellar objects can have. And it opens a bigger question. Are these rare visitors more common than we thought? Or have we just gotten better at spotting them? Why these interstellar objects matter? Each interstellar object is like a message in a bottle, drifting across the galaxy, untouched for millions or even billions of years. They offer us the chance to physically study material from another star system without leaving Earth. They could tell us how other systems form, how planets are built, and how life-supporting materials travel through space. And maybe, one day, we'll find an object that isn't just strange, but impossible to explain by natural causes. These objects are rare, mysterious, and full of secrets. And with better sky surveys, AI scanning, and powerful telescopes like the Vera Rubin Observatory coming online soon, we're going to find more of them. More messengers, more mysteries, more chances to understand the universe, one visit at a time. This is why Decrypted, where we explore the biggest questions in space, science, and beyond. If you're curious about what's out there and why we're just now starting to understand it, subscribe and keep watching, because the universe just keeps getting weirder.